right, Algebra 1, let's dig in. We're getting into some harder word problems. We are working with wind and water current problems. Our essential question is, can you use systems of equations to solve wind and water current problems? We are going to set up charts. So on example 1, let's talk about this airplane. An airplane can fly 3,750 kilometers in 3 hours with the wind. The plane takes 5 hours to travel the same distance flying against that wind. Find the rate of the plane in still air and the speed of the wind. So we're going to start by setting up a chart here. And I know I have the rate of the plane with the wind and the rate of the plane against the wind. I also know that distance is equal to rate times time. So this is my rate. My first scenario with the wind, the time was 3 hours. Against the wind, it was 5 hours. And remember the distance that they traveled, they actually gave us as 3,750. So we can set this up as a system of equation. I'm going to take r plus w, multiply it by 3, and that gives me 3,750. And I'm going to take r minus w, multiply that by 5, and that gives me 3,750. Now what I love about this is we can actually take this 3,750 and divide by 3. So I can totally rewrite this problem as r plus w. Well, 3 goes into this 1,250 times. And 5 goes into this 750 times. So it makes it really convenient. So when I actually do add down, remember we can just eliminate. The w and the negative w can delete, can cancel out. And we have 2r is equal to, well, that's going to be 2,000, right? Yes, and when I divide each side by 2, I know the rate of the airplane is 1,000 kilometers per hour. Now, I can go back to an original. So I'm going to go back to this one right here. And I'm going to plug in r. 1,000 plus what gives me 1,250. When I subtract 1,000 to each side, I know the wind is 250 kilometers per hour. So here are the answers, the rate and the wind to this problem.